Hello there, and welcome back to Life Technologies. My name is David Muita, and in today's session, we are continuing with our MPLS configuration from scratch series, where we take real service provider technologies and break them down into simple, practical, and hands-on configurations. So in the previous sessions, we built the MPLS foundation. We looked at IP reachability in the provider core. Look back, that is IGP. We configured SIS. We enabled MPLS LDP. We configured MPBGP. That's where we did the L2VPN configuration. We learned the concept of URFs, and then we did PE to C routing using BGP as routing protocol. And finally, we talked about MPLS label operations such as push, swap, and pop. This was done in video number 5 actually, and that video is ready. It's one of the best videos, so please create time and watch that. Now, imagine a customer has two sites. I want you to imagine a customer has two sites. Maybe the head office and the branch site. So they want these two locations to behave as if they are connected by a direct Ethernet cable, but physically, the traffic has to pass through the service provider MPLS backbone. Now, that is exactly what VPWS gives us. Okay, so what it does is it creates a private point-to-point layer 2 connection between two customer sites over an MPLS or IP core network. Now, in this episode, we are going to do three things. Number one, we will first explain the concept of VPWS in simple terms for you to be able to understand them better. And number two, we will configure VPWS step by step. Remember, we've already enabled MPLS in our service provider environment, so therefore we won't be able to do that in this particular video. If you want to see how that is done, or you want to see it in action, kindly go back and watch video number 4, and then you can watch video number 5 to understand MPLS label operations before you can come back and watch this particular video. Now, after configuring VPWS step by step, the third thing that we will do is that we will actually do verification and troubleshoot, just in case there's an issue that we will have configured incorrectly. Then we will do the troubleshooting, just like we would in a Railnoc or service provider environment. So if you are preparing for CCNP, service provider, HCIP, datacom, or working in an ISP operation, or just trying to understand how layer 2 VPN services are delivered over MPLS, then this session is exactly for you. So let's get started. So we need to begin with a very basic question. What is VPWS? VPWS stands for Virtual Private Wire Service. It's an MPLS layer 2 VPN service that provides point-to-point connectivity between two customer sites. We've already given you a scenario up there where we are imagining we have two customer sites and they want to connect to each other, but they're geographically separated. But they have to use our MPLS service provider backbone. So instead of the customer buying or leasing a physical dedicated line between two locations, the service provider uses the MPLS backbone to emulate that point-to-point link. Okay, so from the customer's perspective, site A and site B appear to be directly connected, and we actually know they are not directly connected. The provider core is hidden, meaning the customer does not see how traffic moves within the service provider network. We will actually be able to do a trace after you've done the configuration for you to be able to see that. Okay, and the routing inside the customer network is also independent of the provider core. Okay, so the provider simply transports layer 2 frames from one PE router to another using MPLS labels and pseudo wires. And we'll be seeing how those pseudo wires are configured on both Cisco and Huawei. Okay, now to give you a very simple explanation, VPWS is like taking an Ethernet cable stretching it across the entire MPLS backbone and connecting two customer sites together. Of course, physically there's no cable between the two customer sites. The MPLS network is doing the transport for us. That's why the two customer sites are able to see each other as if they are directly connected, or the term here is as if there is a point-to-point connection between them. So why would you use VPWS, or in simple terms, where is VPWS used in real networks? Okay, so in real service provider networks, VPWS is commonly used for dedicated enterprise links between head office and the branch, and it is also used in mobile backhaul circuits. You can also use it in wholesale Ethernet services. The other use is that you can actually use it to do customer VLAN transportation. And lastly, although this is not the entire list, you can actually use VPWS to do migration from legacy list lines to MPLS based services. Okay, so we want to give, or rather, I want to give you a practical example. Um, Assume a bank has two sites. Okay, a bank has two sites. The head office is in Rwanda, that is our head office, and then the branch is in France. So let's do France here. Okay. Now the bank wants to run its own routing, its own VLANs or layer two services between these two locations. So as a service provider, which will be us here. So of course in here we have a few of our core routers, but here is our PE in Rwanda and then our PE in France. Okay. So as a service provider, we can give them a VPWS service, point-to-point connection. So the customer connects to PE1 in Rwanda, and I'm using our lab topology here that I'll be showing you very shortly. So the customer connects to PE1 in Rwanda. The remote sites connects to PE8 in France. So between PE1 and PE8, these are our PEs. We create a pseudo wire, or the correct term is a virtual circuit, VC for short. Okay, so we create a VC. So once that pseudo wire is up, frames entering PE1 from the customer side. So here we'll have an attachment circuit AC, and also here we will have an attachment circuit AC for short. Okay, so frames entering PE1 from the customer side are carried across MPLS and delivered to PE8 and vice versa. So if this is a direction of the source, which means this is the destination. So once we receive those frames, we of course have to do a response or reply back. Okay, that's why we're saying that frames are carried across MPLS and delivered to PE8 and vice versa. Okay, now the customer, from their own experience, so the customer experiences it like a direct Ethernet circuit. So what the customer sees is actually that if you could change the color of our pen, what the customer sees, this is what the customer sees. The customer sees a direct or point-to-point connection between the CE in Rwanda and the CE in France. Okay, so that's just a practical example of how you can view VPWS. So moving forward, before configuration of VPWS, the things that we need to first of all ensure that are in place. Okay, so we must make sure that the MPLS core is already working. So check the following, or this is what we'll be able to check. We'll have to check IP reachability within the service provider network. Loopbacks and are supposed to be reachable through ISIS, which is already configured. We did that in video number 2. MPLS should be enabled in the core. That is all the interfaces participating in MPLS should be enabled. That is within the service provider environment. Remember, our CEs do not know anything about MPLS. They are MPLS unaware, and therefore you should never configure interfaces facing customers or enable MPLS on those interfaces. Okay. We also have to check that LDP neighbors are established, and that this is very important, that PE1 can reach the loopback interface or IP address of PE08. And we'll be able to see why that is, because when we are creating the pseudo wires or the virtual circuits, then we are going to use the loopback IP addresses of these particular two PEs in this case to be able to establish that connection. So that's why it's important that the loopback IP addresses are reachable from either PE device. Last but not least, we should be able to confirm that MPLS labels are exchanged normally. We did video number 5 where we talked about MPLS label operations, that is push, swap, and pop. As a network engineer, you should be able to know at what stage is pushing done, at what stage is swapping done, and at what stage is popping done. And by stage here, I mean in which device. Is it the PE or is it the provider device? Because those are the only two MPLS devices that you can get in your service provider environment. The CE is the customer's domain, but the provider edge and the provider devices, those are managed by you as a network engineer working in the service provider network or in service provider environment. And lastly, you should be able to confirm that the customer facing interfaces are ready, meaning you've configured the customer's side with the IP address, and for the side of the PE, there's no IP address, by the way. And one thing I forgot to mention is that for VPWS, this is a service provider connecting to our PE there, connecting to our PE there. The IP address that you configure here and here, they have to be in the same subnet to work. Remember, it's a point to point. It's like connecting these two devices together like this. Okay, so you can't configure a /31, for example, here, and then configure /26 here, then expect it to work. So it has to be in the same subnet. For example, if you decided to go with 10.1.1.0/24, then the IP that you give in this interface, maybe this is 1, this is let me say 8, this has to be .1, this has to be .8. Or if you decide to go with 10, this has to be 10, this has to be maybe 8. But just to ensure that that IP address is or belongs to this particular subnet. That is very, very important for you to be able to know and understand before we move forward. Very, very important. Okay, so we've done a very brief intro about L2VPN, specifically VPWS. So let's get right into it. So I am going to show you the topology that you're already familiar with. I'm sure you are very, very, very much aware of this topology here. Okay, so if you remember the L3 VPN configuration that was done, these upper devices here were up or powered on. For today, they are not powered on because we are not going to touch them, because we'll be concentrating on the MPLS service provider core or network, and these three devices. So I promise to show you how to configure one legacy configuration of VPWS and another one where we are doing real life scenario. So as you can see, C13 belongs to the company ABC, and then we are going to give this customer APT services. Their VLAN is VLAN 1300. So what will happen is, I think I should power this on because we're going to use this device. Sorry, I have to power this on because actually it's powered on. Sorry, it's powered on because this is my PC. Okay, so what will happen is that this customer will be able to do a virtual circuit between these PEs. Okay, so we'll do a virtual circuit, and then once that virtual circuit is up, then this IDW here connects to this. This is nothing but my local PC, by the way. So I have enabled my local PC to connect to EVNG for me to be able to, exit out to the internet. That is, after we've done the configuration, we'll be able to ping maybe Google or Facebook from this guy. But unfortunately, we will not be able to do the name lookup. So we'll have to ping the real IP addresses of YouTube and Facebook, for example, or any site out there. But we can ping youtube.com from our IGW. That's what we'll be configuring, but it will have to come last, because I want you first of all to understand how we configure typical L2VPN, or what I'm calling legacy L2VPN. So the device in Rwanda, CE11, will have to connect to the device of the CE in France, that is CE10. And we've given them the VLAN 1011, which means you combine 10 and 11 to get that VLAN number. And the name here is peace. So we're just giving the name for identification. It will not really be used anywhere during the configuration, because this is L2VPN. We will not be doing, we will not be configuring VRFs, but I've just given a name just to identify these particular devices here, or this particular company, and differentiate it from the one for L3VPN here that we give a name Amani, and the one that we're going to give IPT services, which is we've given a name ABC. Okay, so as we had said in a few minutes ago, we're going to first of all create virtual circuit. Again, I repeat, just for purposes of understanding, we'll create a virtual circuit between these PEs, where we'll be using the loopback or loopback IP addresses. Then after that, we'll create an attachment circuit, then an attachment circuit. Similarly, for this, we'll do attachment circuit and an attachment circuit. Thereafter, this VC is up and everything is configured correctly, our customer side, then we should be able to ping each other. These two devices should be able to ping each other. And also for our APT customer, we should be able to access the internet. And I will be showing you that practically. Okay. Okay, so we did say that there are a few things we have to confirm before moving forward. So let's just confirm those ones, that we have IGP running. So we can say display ISIS, maybe peer. As you can see, we have a couple of actually 3 peers there. But just to fast track this, or do it quickly, let's just examine the database. Display ISIS LDP. No, it's actually LSDB for the database. So this is how you do it in Huawei. This is Huawei. If you're joining us for the first time, the blue devices you see here, 1, 2, 3, 4, are Huawei devices. These other ones here are all Cisco, including the CEs. They're all Cisco. So it's important for you to know what platform we are actually in. So from that prompt also, because if you do enable here, it will not accept that command. So this is Huawei, and the version that we are actually using here, if I could just show you that, this is the version that we are using for this particular lab. Okay, so moving forward, we've seen that this is our link state database for SIS, and as you can see, we are getting to learn about all other routers within our MPLS service provider environment, which is very good. So that's fine. So this confirms that we can actually go ahead and start configuring IL2 VPN VPWS. So if you want, we could check the same in France. This is a Cisco device. So the command is show ISIS database. And as you can see, all the devices are here. All the devices are here. This is we're in France, that's why we're seeing the asterisk there. For Rwanda, we were in Rwanda, that's why the asterisk is there. But the other remaining devices, this is good because it shows that we have learned, or we have a map of the entire network. And if you can examine the routing table, display MPLS, display IP, routing table. The protocol we're interested here in is ISIS, and as you can see, we are getting routes. Looks like we're getting everything, including our loopbacks, which are in the format 10.xxx. X stands for the device number. So this is the loopback of PE8. This is the loopback of Kenya Mombasa P07. This is the loopback of that should be 5, which happens to be Uganda P05 up here. Okay, so this is good. And lastly, for verification, let's just see if we are assigning labels those prefixes. Display MPLS LSP, and indeed we do. We are assigning labels to those fakes for the equivalent class, or we can simply refer to them as prefixes. That's good. So since we're in Rwanda, let's start our configuration here. So for Huawei, we have first of all to enable MPLS L2VPN command globally. So let's start there and say MPLS L2VPN. Remember, you have to commit in this version for those commands to take effect. Then after that, we can quit. So the next thing that we need to do now, after we've enabled MPLS L2VPN globally, is that we should be able to now configure the pseudowire. Okay, and that is done by this command. Command is MPLS LDP remote peer. We give the name of our remote peer. In this case, our name should be France. Give it a meaningful name for ease of identification. So the remote peer is France PE08. And then in here, you can see we have a couple of options, but what we are interested in is this particular command here, which says remote IP. So our remote IP will be now the IP address or the LSR ID of our remote peer, in this case, the loopback interface of France, which in our case is 10.8.8.8. And that's it. We quit, we commit. Okay, and lastly, we go to the interface that is facing the customer. Remember, we are dealing with C11 and C10 first, then you can come back to C13. So the interface facing the customer here is Ethernet 107. But remember, the customer here has a VLAN, so we have to create a sub interface so that we can actually be able to use our VLAN here. So we tag the traffic equally. This particular physical interface in France, we also have to create a sub interface to tag the VLAN 1011. Okay, so we go to the interface. It's it 107. Okay, and then we use a dot. The VLAN is 1011. Okay, so in Cisco you have to do encapsulation.1q. The command in Huawei is VLAN type, then you give the VLAN number. No, sorry, the VLAN type .1q, then you give the VLAN number 1011. You can give a description here and say that this is our NNI with maybe NNI with C11. Just some description, it's good. So you commit. Okay, after committing, now here is where you're going to configure that pseudo wire or virtual circuit that we spoke about, and the command here is MPLS L2VC. Sensitive context sensitive help tells us that we need to give an IP address of the target peer, and our target peer is this particular guy here, France P08. The IP address is again the loopback interface, that particular peer, which is 10.8.8. And this is very, very important. We have to use or give identifier of L2 virtual circuit. It clearly says here, and that is an integer. It's an integer. For those who remember their math or mathematics, then you know what an integer is. So in this case, our identifier is the VLAN, which is 1011. So this VLAN has to match on both sides for this virtual circuit to be up. If it doesn't match, then it will not be up. Okay. Then after that, these other commands here are optional. So just hit enter. We're just doing a very simple configuration, and then you commit. Okay. And Huawei has this very good feature that you can actually, once you're in interface view, you can use the command display this to show all the configuration under that particular interface. As you can see, that is our virtual circuit right there, or our pseudo wire, and our description. And this, we are tagging this traffic with VLAN 1011. That's it. We quit. So we can view the status of our configuration or our L2 virtual circuit. And the command is display MPLS L2VC, and then you can go ahead and give um, the virtual circuit ID that is 1011, actually, not 1012. As you can see, we are told that our attachment circuit is up, but session is down because we've not configured France, and the virtual circuit state is down also because, again, there's no communication with France. So let's go and fix that. Let's go to France. Conft. Now here I will have to create a pseudo class because when we're doing MPLS traffic engineering next, I'll be able to show you the easiest way that you can actually be able to influence how traffic moves within our MPLS service provider. Remember, it's a point-to-point connection. It's an L2 connection, but within our service provider environment, we can be able to influence how that traffic goes or how that traffic moves within our environment before it goes out to the customer. Now, the customer, remember we said the provider call is hidden from the customer. So they don't know how, if they do a trace, they will not see those hopes. For them, they will just see a direct connection. But inside our MPLS service provider, we can be able to influence traffic. That's why I'm creating a pseudo here. For Huawei, it's very easy to be able to influence that traffic either for L2 VPN or L3 VPN. But for Cisco, it's done differently. So for L2 VPN, we have to create a pseudo class. You can remember we created remote remote peer in Huawei. So let's do the pseudo class here, pseudo class, and give it a name. It's a word, and we can say maybe Rwanda PE0. Yeah, Rwanda PE01. Let's say this is a class. So if we hit enter, we can see we have options here. So we can say encapsulation because we want to encapsulate our L2 frames with MPLS. So encapsulation. We have we have three choices here, but the one we're looking for is MPLS. MPLS, and we are done there. After you've done that, remember we had earlier we were only having 4 options, but after we've enabled MPLS, this command here, now we have a couple of options. So the one that I was looking for is actually this particular part here, preferred path. So later on, we'll come and use this preferred path to influence how traffic will move within our service provider environment from PE8 in France to PE1 in Rwanda. We can decide that traffic should use this direction, or it should use this direction, or whichever direction that we'll be able to use based on the requirement of the customer. Okay, that's important to know. So after we've configured our pseudo class, now we go to the interface. Remember again here also we will have to do a sub interface and tag the VLAN. So the interface that connects to here, the physical one is gig6. So interface gig6. First of all, let's ensure that this one here is not shut down. So not shut down. And then we go back and again now we can do the pseudo wire. So sorry, we can do the sub interface. .11, and we say encapsulation 1Q, then we give the VLAN ID. And now here the command to configure the pseudo wire or the virtual circuit is xconnect, and then sensitive help here we have IP address of the peer, which is the loopback interface of Rwanda PE01, which is 10.1.1.1. And then remember we said that the virtual circuit ID has to match. If you give different virtual circuit IDs, that virtual circuit or the VC will not come up. So ensure that you've given an integer and it should match on both sides. So the VLAN we used was, or the virtual circuit ID we used was 1011, and I think that's it. No, actually not, because we have to choose. Had we not configured a pseudo class, we would have just gone encapsulation MPLS. Let me just show you that encapsulation MPLS. But since we configured our pseudo class, then we can invoke it here and use it. Pseudo class. Our pseudo class was what was the name that we gave? This is the name that we gave as our pseudo class. Just highlight it, copy and you paste. That's our pseudo class. Now wait and see magic happen here, because in in Huawei you have to manually configure the remote LDP, but in Cisco, once you give this command, you'll be able to actually see that although we are not directly connected between Rwanda PE01 and France PE08, this particular two PEs will form a remote LDP peering. There are two types of LDP peering: local, which is the peering that you do or you establish when you are directly connected. For example, UGP05 and Rwanda P01 have a local LDP peering. Equally, P01 and P06 here have a local LDP peering, but we'll be able to establish a remote LDP peering between Rwanda P01 and France P08. So it normally takes time for this to come up, because if we go and confirm that, let's show MPLS LDP neighbor brief, you can see it is not yet up. So we were able to confirm the virtual circuit here status using this command. So the equivalent, there you go. LDP has actually come up while I was showing you the command in Huawei. So let's run this command again. And as you can see, we have established an LDP remote peering with our PE in Rwanda. Okay, so let me show you something here so that you can understand what I mean by remote peer. So these two peering here, as you can see, I want you to pay attention very closely. Yeah, there. So this one here, as you can see, they have something. They actually it is what they don't have. Okay, so this one here has this particular keyword here, targeted hello. Targeted hello. So if whenever you see this, then just know that this particular LDP pairing is a remote one, because 10.8.8.8 and 10.1.1 are not directly connected. As you can see, those that are directly connected, there is no that targeted hello anywhere. You can't see it at all. You cannot see it. But for the remote connection, you can see we have a targeted hello. So that command that we gave in France to configure our pseudowire, this particular command here automatically created that particular remote peering for us. But for France, we had to give, let me show you, for France, we had to give it manually. Display current configuration. Let's filter it, include MPLS LDP. We had to give this particular command to be able to establish MPLS LDP peering of a remote type. Okay, so our virtual circuit is up. We were able to confirm earlier in Huawei. This was the status. So let's run this command again. Let's give ourselves some space, then run the command. And as you can see, we are being told now that that administratively our pseudo is sorry, our yeah, administratively our attachment circuit is up, our virtual circuit, which is a pseudo is up, and as you can see, it has been up for 2 minutes. This is when it was created, but this is when it was actually up, and it shows you the time right there. Okay, so the equivalent command in Cisco is show MPLS L2 transport, then virtual circuit, then you give the virtual circuit ID, which is 10, 11. So if you just hit enter here, it would give you a summary of that particular L2 transport virtual circuit. As you can see, that is the local interface. It's a sub interface, and the local circuit type is uh, Ethernet VLAN, and that is the VCID. That is our destination address, which is Rwanda PE01. And then status here is very important. It should be up. So this is a brief summary. But if you want to see details, you give the keyword detail, and this gives you everything that you need to know about this attachment circuit or this L2 VPN configuration you've configured. As you can see, this is everything that you need. And again, that keyword targeted hello is right here. Okay, so this shows that everything is done. Now, the next thing is to go and confirm. Remember, we had pre-configured IP addresses. I said all our CEs are Cisco. We had pre-configured IP addresses. So show IP interface brief. You can see this is our IP address. Can we ping ourselves? Ping. Indeed we can. So this is C13. Sorry guys. C11. C11. Show IP interface brief. Yes, this is our IP address that I was looking for. Can we ping ourselves? We can ping ourselves. Remember we said the IP address have to be in the same subnet for this to work. So we can ping ourselves. Let's go to C10. Enable show IP interface brief. My apologies, interface brief. And you can see this is our IP address here. Can we ping? Yes, we can. So by now, you should know that our last octet here corresponds to the device number. So this is 10 because it's C10. The other one was 11 because it's 11. As you can see, they're in the same subnet. So we were able to ping ourselves. Can we ping our remote PA, our remote CE that is? The first one will drop because of app. Let's see. It appears we are not able to ping. Why are we not able to ping? Why are we not able to ping? This is where now we do the troubleshooting. I know why. I know why. I know why. And I think you've guessed it too. So we did sub interfaces on our PEs. We have to do the same on our CEs. So because we can see this interface is actually mapped on this IP address. Sorry, IP address is mapped on a physical interface. So let's go and change that. Conft to show run interface is 00. So interface is 00. Then remove that IP address from here. And then now we create our sub interface, which is 1011. Encapsulation.1q 1011. And then we reissue the IP address. Save that. And we ping ourselves as part of verification. We're good there. Let's go to C13. Show run interface is 00. Then conft interface is 00. No IP. You can even say no IP address. No harm. And then let's create our sub interface. If you don't give the word encapsulation.1q, if you give this command, if you assign an IP address here, if you assign an IP address, it will fail, and this is the information you will get. Okay, so let's go. I know maybe you're wondering why we're doing it, so let's configure encapsulation.1q 10.11. And now we can give the IP address. And remember to save your configuration always, because this is very important, just in case your machine goes off and you had not saved, so you will lose a lot. Can we ping ourselves? Yes, we can. Now then, let's see if we can ping. We're in C10. Let's see if we can ping C11. And indeed we do. So the ping is working, which means communication. We have communication end to end. So remember we said that for L2VPN, the MPLS core is actually hidden. Okay. Unlike for actually, I'm going to turn on this so that we can just I can just show you something. I want to drive the point home. So for L3 VPN, the customer is able to see hop by hop which hop traffic takes, for example, from Rwanda to France. But for L2 VPN, customer is not able to do that. It's transparent, it's hidden. It's like they're not aware. Remember, we said it behaves as if these two connections are directly connected, but they have to go through our MPLS as supervised environment. Okay, so if we trace 172.16.0.11, we'll only be able to see one hop. Let's wait for it. Are we tracing this the correct thing? What happened? Sorry, we are tracing the wrong. We are tracing the wrong IP address. It's supposed to be 17. Sorry about that. So if we trace this, we'll only be, so this one will just go to, we'll only see one hop, and that is what the customer sees. There you go, and then it stops. So to speed this up, you can just use the word or the keyword numeric. So we have established point-to-point connection. One last thing that we need to do, as you can see, we say that L2VPN enables the customer to run their own routing of their choice. So we have these loopback interfaces here. If you can just show run interface loopback 0. It's /24. So we want this particular, because if you can show IP route, the routing tables of us, we don't have, for example, in C10, we don't have the loopback interface of C11, which happens to be show run interface loopback 0, which happens to be this IP. So we don't see it in C10. So we can quickly run OSPF here so that we can have that reachability. So quickly do conft router OSPF even 1 or even 10. The router ID here will take the loopback interface, and then we can say network 10.10.10.0. It's a /24, so wildcard mask, and then this should be in area 0. Okay. Or we have to do another network, that physical connection, that is 172.17.0.0/24. That's correct. Let's go and do the same in C11. Conft router OSPF. Remember, the OSPF process ID doesn't have to match. Okay, so we can even use one here. This will come up. Router ID 10.11.11.11. So let's give the network 10.11.11.0 wildcard mask /24. So we give that area 0. Areas will again have to match on this one. Lastly, let's give that network 172 17.0. I should be able to see neighborship come up, and indeed we do. Show IP or SPF neighbor. We have full, we're in full terrace and we are the DR here. So again, so let's see, show IP route. Perfect. So we have the loopback interface here. Can we ping it? Yes, we can. Can we trace? Numeric. Of course we can. Now, the thing about loopback interfaces being /24s and you enable OSPF on them, they will be advertised as a /32, as you can see. So let's change this behavior by changing the network type of that loopback. So conft interface loopback 0, IP OSPF network type. I think it's point to point. There you go. Let's also go and change the same in C10 conft interface loopback 0. Before we do that, we can, yeah, interface loopback 0. IP OSPF network point to point. Okay, so earlier we were able to see in our routing table in C11 as /32. Okay, so let's see if that has changed after changing the network type, because by default loopback interface the network type is loop. So show IP route, and now you can see we have a /24. Okay, what about here? Show IP route. Indeed, you can see we have a /24 also here, and we have reachability, full reachability between CE11 and CE10. So I know I promised you that I'm going to talk about this particular customer here for IPT. This video has already gone for too long, so kindly allow me to stop here, and we can come back with a very short video to just explain this part where we are giving the customer IPT services. They are connecting to us before they can get whatever content Google is giving here. So that has been our time, and thank you so much for being with me all this time, and looking forward to our next video. Until then, be safe and bye bye.